Okay, to work on these abstract classes, I will start a new project, and I just put the name intro abstract classes. And there's something here. You see this create main class, because every time when you design, when you create a new project, it will add a new class with the same name of the project and with the public static void main that's inside of it, which is like the main program. What I'm going to do, actually, I'm going to change it to something else to make it something like program. And now what it's going to do, it's going to just create a new project, and it's going to add inside this intro abstract classes the package, this class program, which holds the main. Just instead of doing it and then coming back here and rename it to program, I just put it right away, because I'd like to always keep the main clearly separated in another class, to just to clearly show that, and also to be able to easily find it here. Now every time I'm going to create a class, I'm going to be just creating another class, and here is where I'm going to test those classes that I'm going to create. So let's just talk about these abstract classes. So like a general overview, what is an abstract class when we don't have well, let me just, before going to the slides, I just would like to give you an example of an abstract class. And let's look at something we did before, and let me see which one we can use. Well, maybe the shape, the easiest one with shape, if I can find it. And this is maybe this one. Yes, when we have the shape and everything. If you remember, when we're trying to do this exercise, if you look at the class shape, we're trying to find get area, and then in the get area, I'm trying to solve this. If you go back here, and you see, remember this thing? So this is the class. We had get area in shape and get area in rectangle and triangle. I told you, okay, let's just practice polymorphism on this thing. And we did something that's like some kind of, in the program, with some array with different shapes, and then we just called get area for each one of the elements of the array. And this get area is going to be from rectangle one time, from triangle another time, and from shape another time, because this is an example of polymorphism, which shows that this get area is polymorphic, which means it takes multiple forms. Sometimes it's an area of a rectangle, sometimes if it's an area of a triangle, and sometimes if it's an area of a shape. But this is possible because of something that is called, remember, something like this binding, late binding or dynamic binding. So this is what happens, because at runtime, when the compiler runs the code, when it reaches this line, it has to check, okay, what's the object related to this one. It tries to find, oh, this is a rectangle, then it calls the get area of a rectangle, and then for the next iteration it goes to check, okay, what is the object for this next element, and then it's going to call the method from that object, and this is the polymorphic behavior.
So it take a long time?
No, it doesn't take much, because it's all quite, it doesn't actually, you don't feel that it takes any difference, because this was happening, but we never saw it because we just never talked about it. But now, while talking about it, we realize that something is going on in the background, and I'm just explaining. It doesn't take much because everything is already available. Okay, now my point. Remember this get area, we had to take a decision and put -1. Why is that? Well, because this polymorphism relies on overriding. And we need to have get shape here, so when we use this, not here, when we use this one get area, remember that this array is of type shape. So in order for us to be able to do that, we need to also have some get area in the shape as well. If I remove this, the outcome of this removal is going to be, I'm having a problem. First of all, these are just because it tells me, oh, you say you override something, but there's no overriding, so this is not a big deal. I can just fix it by just removing this override. But for this one, it tells you the get area doesn't exist for in class shape. So we had to do something just to accommodate the fact that we need to have this kind of same method name in also in the base class of the other subclasses, so it can work. But this -1 doesn't make any sense because we just did it as a fix, try to fix our code to make it work, but we don't really need it. So the abstract class addresses this issue. If you have a method that you, first of all, for many reasons, but one of the reasons is that you don't want to put the code here, but you want those who are implementing this class, who are deriving from this class, who are inheriting from this class, you want them to have this method in their definition. Now look what is going to happen now. I'm going to say, in this class shape, I would like that to have an abstract method get area. And look at the abstract method get area. It's a method because I have this double opening and closing parentheses. You can have different arguments if you need to have them, but you don't put the body of the method. You just put the method header. Yes. Yes. No, what this will do, let me just, for example, remove this get area from here. What this will do is it will force the others to implement this abstract method. So first of all, it tells me, okay, this abstract method is just a way to say, in this class shape, I have a method that all my descendants of this class shape will have to implement. So I'm not saying what's the code of this get shape, but my children will have to, because they will need it, so they will have to do it. But in this class, I don't need to do it, and this is how I can say that I don't want to do it, but the others will have to do it. So I'm just adding this abstract before the return type, and the rest is just, I'm removing the, I don't have the class definition, the method definition. The body of the method is gone, I just keep the header, and that's what I want. The others will have to implement this, and let me show you this. But before that, let me fix a problem here. When you have an abstract method in a class, this class now becomes special, because not all of the methods of the class have a definition. I know what toString is, I know what these constructors are doing, but what this getArray is doing, I don't know what it is. Then something comes is that I have to make also the class abstract. If I have one method or many methods that are abstract, the class will be abstract, will have to be abstract. And what does it mean that a class is abstract? It means this: when you try to do something like this, you can't. If you try to do something like this, is what I'm just make it clear what is not allowed anymore. Shape s equal new shape. Okay, new shape, and that's it. Now check what the error message is telling me. Shape is abstract, cannot be instantiated. Once it's abstract, you cannot just do something like this. Why? Because what if it was allowed, what if someone do this get area? What is the code of this get area? We don't have it. It's abstract. So how comes it will allow you to instantiate something that doesn't have the code? So then, when you have an abstract method, one or more, just one is enough that to make the class abstract. And what the class abstract does, it puts a condition on the descendants of that class. All those who are inheriting from that class will have to implement get area. And that's why if you look here, let's try to understand what is the error message. For example, in rectangle, it tells me rectangle is not abstract and does not override abstract method get area in shape. So if I click on this button, it is going to help me, give me two options. when you're inheriting from an abstract class, you have two options. Either you implement the methods that are abstract from your parent, or you become abstract as well. Two choices. Again, when you inherit from an abstract method, when you inherit from an abstract class, you have two options. Either to implement the abstract methods of that abstract class, because there are some, for example, in this case, get area. I need to put the code of that get area. So that's one option. The other option, if I don't want to, I'll make the class abstract. And then the subclasses of this class will have to implement it. It's like this get area. Either I implement it myself because I'm inheriting from an abstract class, or my descendants who are going to be doing it. But someone has to do it.
This my question is about if you want to do an abstract class, that's okay, abstract.
Yes.
If you want to implement, you have to do an extend, and after that implement something.
So if I have an abstract class
Yeah, that's okay.
that has an abstract method,
Yes.
okay?
Okay, if you want to implement.
If you want to implement, look, I'm just clicking here. If I click implement all abstract methods, it's going to add get area, and it waits for me to put the code. I need to put the code of that get area. So actually what I'm going to do, because the code exists, I'm just going to bring it back, and then I have it. So now it doesn't complain anymore, because this get area is being defined, implemented in the child. But if for a reason I don't want this, for whatever reason, I don't know, the other option that I have to fix this problem is to make the class abstract. Which means I'm inheriting get area, but I don't have the code for that, and someone will have to put the code, but if it's because not in this class, because I decided not to implement it, so those who will be inheriting from rectangle will have to then two options: either implement those abstract methods or become abstract themselves. So what we're going to be doing, we're going to be doing this implementing those abstract methods, and the same thing for this one is the same error message. Triangle is not abstract and does not override abstract methods, so it has to override that abstract method. So now that I've put it, there's no problem anymore. The last problem that I have is this one. I'm trying to instantiate a new shape, but shape is abstract, so you cannot instantiate from an abstract class, and that's why this is not going to work. You cannot do this. That's the result of making a class abstract. You cannot instantiate from it, so I cannot do something like this. So what should I do? Well, just remove it and use some other things. Let's make a rectangle or whatever. Let's put something that can be instantiated, which is not an abstract class. So now there are two types of classes: abstract classes and non-abstract classes. Well, non-abstract classes, they have a name again. They call them concrete classes. We're going to go back to that in the slides. But the idea is that the abstract class is abstract and means I cannot instantiate an abstract class. I cannot do something like shape, whatever, something shape s equal new shape. I cannot do something like this just because shape is abstract. That's the only reason. If it's not abstract, if I don't want it to be abstract, well, just remove this abstract. But then you cannot keep it abstract while having an abstract method. So then you have to remove this and put the code for this one, and then you're not abstract anymore. That's a weird return.
So I can't create objects in the main class
You cannot create object
of the superclass if it is abstract.
if it's abstract. Yes, if it's abstract. So again, to make it abstract, I mean I remove the class declaration, the class definition. Oh, not the class, the method implementation. Then I put abstract before the return data type, and then because this is an abstract method, the class that contains it becomes abstract. That's why I got the message. Now, if it's abstract, it means that I cannot create an object from that abstract class. For the very simple reason that what if I allow this to happen, what would be the result of this code? This get area, s get area. But there's no code for this. If you go to here, what's get area? Well, we mentioned that it is abstract, which means the descendant of the class will have to implement this get area. And so this class does not have any implementation for this get area. So which means there's no code that needs to be executed with this get area. And then you cannot have this at all just because of that. To not have, so you don't have this kind of thing. The benefit is that you have something that makes more sense. Why did we have before that? What we had get area with return -1. Did we want really this shape to have an area of a shape? Which doesn't make sense. But this is more realistic because we have a shape that has some color. Okay, fine. But it should have some get area because the others are going to be given the area. But I don't have enough information to be able to calculate that area because it depends on the type of the shape. If it's a rectangle, there's a different calculation. If it's a triangle, different calculation. If it's a square, if it's a circle, etc. So this is a more accurate representation of the current situation, of the real life situation. Does abstract help? What do you mean, does abstract help, if you'd like to enter it? You don't have to import anything. There's no import about it. It's just a keyword. The same as public, there's abstract. So abstract is a keyword. So there's no kind of, import that you have to do. Yes, exactly. That's what I'm doing here. In the I can use it as a type, but I cannot instantiate it. You see, I'm using it as a type to put some other subtypes, like rectangles that are shapes and inheriting from shapes, because of them are extending shape. So I can do something like this. I can put them in a shape, but I cannot instantiate an object of an abstract class. So that is the main thing about the abstract class. There's some small details, but we'll see them later on. Any questions up to now? No? Yes?
So we prepare the method to use it in the subclass, right?
We will prepare
The method to use it
in the subclasses. Yeah, exactly. When you have an abstract class, you're forcing all your subclasses to implement all the abstract methods. You had a question? You have something? Okay. What I wanted to say though is that an abstract class does not have to have an abstract method to be abstract class. Which means if I remove this is still okay. Which means I can have an abstract class without any abstract methods. But the result is the same. I cannot instantiate this class later on somewhere. I cannot even do this shape s equal new shape. Why? Because it's abstract. So sometimes you can prevent some classes from being instantiated directly because you don't want that, because you want them to instantiate some of their subclasses instead. Yes.
If I want to put the method
Like this.
without abstract,
Without abstract, yes.
is it allowed?
It's allowed, yes, of course.
Without returning something.
Without what?
Returning something.
Without returning something? Here? Without this?
No, no. As long as the class is abstract.
As long as the class is abstract, you just have to, you say, I don't need to put, this abstract keyword here, just put it like this. No. Why? Because an abstract class does not have only abstract methods. It can have a mix of abstract and non-abstract methods. Like for example here, we had the mix of, let's just bring back this abstract. We have a mix of an abstract method and this is not abstract method. So I can have a mix. So if you don't put this abstract, Java will not know that is this just a mistake or you really mean that this is an abstract method. So in order to distinguish between not a mistake, but just this is clearly an abstract method, so we put the abstract keyword before. Yes.
The meaning of abstract, like process.
Sort of something that cannot be instantiated. That's what it means. Some kind of protection against instantiation. You remember this? We've seen before something that we can put in the class. We've seen something final. What does final do? No, that this would be for maybe a variable. A final variable cannot be changed. But for a final class, there's another meaning. Cannot be inherited from. If I put final, someone tries to inherit from this, it's going to tell me, sorry, you can't, because shape is final. Now this is a restriction on the class. Now we are just discovering another restriction, which is abstract, which makes I would like to have the class, then I don't want to define all the methods, and also no one can instantiate from it. So these are again other restrictions that I can add. So this is the main idea behind that. All right, shall we go to the slides a bit? The slides are again the example of this employee, hourly employee, salaried employee. So you have another example, but they have like some method same pay, which is exactly like this get area that we were using. They have same pay somewhere in employee, etc. So just give you this example. So ideally, we would like to postpone the definition of this method until the type is known, which is the same thing. We would like to postpone the calculation of the get area until the type of the shape is known. So that's the introduction to that. So in order to postpone the definition of a method, Java allows an abstract method to be declared. So it just has a heading but no method, no body, and the body has to be defined in the derived class. And the class that contains an abstract method is called an abstract class. But an abstract class does not mean that there is always at least one abstract method. That's important. You have to distinguish between the two. If there is an abstract method, automatically the class is abstract. It has to be abstract. But if the class is abstract, does it mean that it has to have at least one method that is abstract? No. We can have an abstract class with no abstract methods. So we can have that because we don't want people to instantiate from this one for some reason. So that's the idea. Okay, hold on. And there was something. When you put a method abstract, it cannot be private. You cannot have a private method abstract. Why? For the obvious reason. We want this method to be implemented by the subclasses of this class. So if you put it private, it's not going to be inherited. So there cannot be implementing this one. So it's impossible. That it should never be private. So that's the idea. Okay, so I think all these things we've been talking about it. Remember, a class that has no abstract methods is called, unless it's declared and defined as an abstract class. There are abstract classes and non-abstract classes. The non-abstract classes are concrete class. A class that has no abstract methods is called concrete class. That's what I won't like you to understand why I said unless it's defined as abstract, because let me show you this. What if I remove this one? Just look at this class alone. I don't care about the other problems, but this class alone, it's an abstract class. Is it a concrete class? No, it's an abstract because it has this abstract keyword here. Does it have any abstract methods? No. So if you look at this definition, it's not really accurate. A class that has no abstract method is called a concrete class. It's not really complete if it's not declared as abstract. So if it's not declared, the class is not declared as abstract, then it's concrete. It's a concrete class, just as opposed to abstract. But again, this is just terminology. So you cannot create instances of abstract class. That's what we were doing. We were talking about. Okay, so I think you can use it as a type. That's again something that we've been talking about as well. So let's just now go practical. We would like to implement this example. So if you click on this, it will enlarge, and you can have this more detailed exercise about the shape. And as you see, it's put like this as abstract. Notice these symbols. We've seen before that the pluses means public, the minuses private. What are those? Protected. Whenever it's like this, it means it's protected. Okay, so this is protected. These are the abstract methods. They put them in bold and italic. You can see the bold, italic, they are abstract. So we want you to make these abstract, and here you're going to, of course, implement those abstract methods here. And you can see it's get area, get perimeter to string is the same names, but in this class we don't want to implement them. We just would like to force our subclasses to implement them. So you have in each of these classes constructors. It gives you the data types of the arguments, and then getters and setters. So that's what you have. So I'd like you to implement that. Look at this square, which is inheriting from rectangle, because a square is a rectangle, just a special rectangle that has the same length and width, right? It makes sense to make it inherit from here. It doesn't have any special instance variable, but it will have to deal with the constructors, because this constructor needs to call the others. So that's another interesting feature that I would like you to deal with it.
Is it like a rectangle? There, I think there is three constructors.
3 constructors, yes.
Okay.
One that takes no arguments, one that take 2, one that take all of them. So of course you have to call the other ones from the superclass to be able to do that. Okay?